Okay, it's 11 on the dot. I think we can start today. So welcome everyone. My name is Maciej Wilamowski. My great colleague Marcin Kaźmierczak is with me today. And
Hello.
Today we will have a great pleasure to tell you a little bit more about our solution called LinkSense. So before we start, I would like to tell everyone that this webinar will be recorded, and the recording from this webinar will be available to pretty much everyone later on. So if you want to review something later on, you will also have the access to the recording. I really would like to encourage you to ask any questions you want, anything at all. This webinar will have like this very demonstration-oriented plan. So it's not going to be just dry presentation of slides, but we want to show you the solution in action, show you how to configure it, how to use it, and so on. So I would really like everyone to be encouraged to ask any questions you want regarding pretty much anything. So maybe as a form of an introduction, like what is LinkSense and how it came about to be. So I don't know when exactly it was, but some time ago, me and Martin were talking, and we said, well, actually Martin said that
Yes.
he saw in some organizations that there is a good need of software that allows for the monitoring of, let's say, links. Yeah, so the connections. Because some customers have very large networks with multiple sites. Sometimes they have multiple server sites, multiple applications, load balancers, and stuff like this. And I said, like, my first reaction was like, but there must be something like this already. Like, I'm 100% sure that a software like this already exists. We are living in a time where basically there is either a software or a library for pretty much everything. And I was like, come on, Marcin, there must be something. But we looked, and obviously there are certain solutions. There is Zabbix, there is Nagios and stuff like this, but we were not able to find a system that will be open source, very simple to configure, very simple to use even on large networks distributed with multiple nodes, multiple sites, multiple server rooms. So I said, well, but what you're asking me to do is very simple to do. Let's write it. Because when we started, we say, well, it would be nice to just, make a ping from time to time and check the HTTP request to HTTP request to know, if the website is up or not. So this is how it started. What is our design philosophy? And later on, I would like to tell you about tasks and features, and obviously show you a live demonstration, and also tell you something about something that will be in our next release very soon as we finish testing, that is Sycope integration. But as I mentioned before on my LinkedIn posts or other places, I want to do other integrations as well. All right, so what is LinkSense? In the description, I would say that it is basically a high-performance asynchronous Rust-based distributed network monitoring solution designed for deploying multiple lightweight agents that collect and report network performance metrics to a centralized server. And this is a very long sentence, but it actually tells you almost everything that you need to know. And I will dive a little bit, into detail. What do we mean by that? So let's start with the use cases, because when we think about use cases, it's going to be much easier to understand the philosophy and the design features. So we want to be able to monitor uptime in very large networks from the point of view of endpoints that are probably geographically located in very different points. We want to monitor the performance of both application and network. And what we actually can do when we have those possibilities is we can evaluate load balancers, we can check DNS health, we can have statistics for different server service level agreements. We can monitor SSL certificates if they're valid whenever they expire and stuff like this. There are probably even more use cases, but these are the ones that come to us from the top of our head. There's a question if there is a possibility to enable subtitles and transcript. I am not certain about it. I'll refer to our organizer, Magda, if she's able to turn it on. Maybe that's really a good idea. All right, so the first thing is that we have the split for agent-server model. So this was the core of the idea of how we organize data exchange. Because if one of our first goal is to have ability to have multiple agents in different locations, then having a central server where those agents send their data is a logical consequence. Why it is a logical consequence? For two reasons. First is security. Because we have this central server to which agents actively connect to, we can run our agents on anything with firewall enabled as, deny incoming, allow outgoing. So we don't need to have any open ports when our agent is running. And, not having any open ports is, I think, very
ideal.
Good from the security perspective, because, we all heard about different cases where, the agents were hijacked one way or another. And then it's a very, very big security threat. So we decided we want to have it this way. The other thing is that, okay, you need on the server side to have just one machine that have open ports to collect the metrics, but it's much easier to take care of one machine with open ports than with many, many more. So yeah, we are pushing the metrics to the server. And there is one more great advantage that we'll show you today of having the central server and agents to connect to the central server, because we are able to reconfigure our agents from the server. So there is an even option to have a bulk reconfigure. Yeah. So imagine that you have, I don't know, one site per voivodeship, and there are, I don't know, 16 agents or even more. And if you need to, add one task per agent, it's a really, really nice feature to have to be able to reconfigure them all with just one simple addition of one config file. Okay, so again, agents, very small binaries. They execute tasks that you specify them to do. Everything is stored locally in SQLite database. So this also makes the installation very, very easy. The requirements for deployment of our agents is basically as low as possible. They do all the tasks they are designed to do. And then every 60 seconds, they create aggregated measures. And then they send those aggregated metrics to the central server. And again, if they are enabled to, they check if their configuration is up to date. But it's also possible to operate the agents in a fully standalone mode. And again, the server receives the metrics, store them locally in SQLite database as well. So the deployment is also very easy and very simple, and provides the ability to redistribute the configurations to agents. All right. So again, what is the design philosophy? So local first architecture. So no loss of data, even if the server is temporarily unavailable. Agents to continue monitoring during the network issues. Local query capability for debugging. Aggregation strategy, we decided to have this 1 minute intervals. There is no definite reasons for, this is all SQLite. Everything is done in SQLite. So I was answering one of the questions on the chat. So we decided that if you want to have high frequency testing, so I don't know, you want to ping something every second or every 5 seconds or stuff like this, and for some reason you might want to have large number of agents, like 100 of them, it seemed to us that sending those aggregated metrics on 1 minute interval is the best trade-off between accuracy and the amount of data you have to send and so on. And again, we want to have a configuration as a code, so everything is configured via text files in TOML files. All right. So this is it when it comes to slides. And now I would like to move to telling you about and showing you how everything works in practice. So I would like all of you to visit the website on GitHub. So the link was provided in chat. It's very easy to find by now. And we put a lot, and I mean a lot of effort into documenting everything as good as you can. So obviously we were able to do this because probably there might be one of the questions about it. We were using Cloud Code for both development and documentation, but this is not a vibe coded software. Yeah, so I put a lot of effort into designing the right structure to reviewing every single line of code. But yeah, let's be honest, developing everything with Cloud Code or any similar tool right now accelerates your work a lot. The same with documentation. Every part of documentation was, like, in terms of contents, design, structure, and so on, was designed by me. But yeah, I'm trying to review it and keep it up to date with help of stuff like Cloud Code. But again, it's really, I did quite a lot to, get rid of the vibe coded documentation of a lot of bullshit. I made sure that there's only everything you need and everything you might use. So again, when you go to this repository, you will see that there are README for pretty much everything. Yeah, so there is a README for the whole project, for agent, for server, and for each individual task as well. Yeah. So when we go to README agent, we will see pretty much everything that we need to know. So the key feature is that if you want to use communication with a server, you obviously need to provide the address for the central server and the API key to this server that you configure on the server side. You can also use the agents in the local only mode. So if you want to use LinkSense as your personal project and you don't need a central server, and you can view the database via SQLite or some other thing that you have to, I don't know, visualize data or have any kind of alerting, you easily can do it locally. This is also the reason why we chose SQLite. This is the reason why we chose those particular database structures, because as you will see in a bit, the database structure is very, very simple to make it easy to integrate LinkSense with anything else you might want. So obviously, if you want, you can build it from source, but we have GitHub Actions for releases. So if you don't want to compile from sources by yourself, you can download for multiple architectures from here. All right. So when you have your program, one very important note on Linux deployment. If you want to run multiple pings on Linux, you need to change the configuration of your systems a little bit to basically add either this particular user or process to the ping group. Yeah? Why it is like this? Not everybody knows this, but the way we do the ping connection is kind of restricted on Linux. Over the years, the way in which it was enforced or restricted in Linux also changed a little bit, but we actually have two possibilities when we developed the software. So we either use the ping as a basically system tool, so it's only a wrapper around the system tool of ping, but then we lose the ability to do it in high performance with asynchronous execution. Yeah. So we decided, okay, we want to have high performance, we want to have asynchronous execution, so therefore when we are on Linux we need this permission. So the configuration, as I said, is very, very simple. You actually have one configuration of the agent itself and one configuration of tasks. And the configuration of agents looks basically more or less like this. And when it comes to tasks, they might look like this. So in the file of tasks, we say I want to define a new task, and depending on the type of the task, there might be slightly different configuration. But again, it's really straightforward. All you need to do is have one or two and then copy, paste, and modify. There should be absolutely nothing surprising. And like I said, every single task has its own short README, so that you understand. Again, I'm also trying to be up to date to tell you which libraries from the Rust ecosystems are used underneath. So again, this project is very open source, very permissive license, very open. And then again, there are multiple examples of the configuration with the description of the full configuration. All right. So let's see how the server configuration looks like. It's probably even simpler. You just need to have some sort of listening address, have your own API key, tell me where you want to store the configuration of agents, what's the size of the bandwidth test, and that's it. Okay, so let's go back to the list of our tasks and go over them one by one. So obviously we have ping to know how fast the packets go back and forth in the simplest possible way if we have any retransmissions or packet loss. And then we actually, when we were developing the tasks, we started with HTTP GET, but then we said, okay, but if I have HTTP GET, I actually also need to have TLS handshake and I need to have TCP connection. And sometimes you don't need to do TLS, you don't need to do HTTP. All you need to check is if you have an open port for TCP. Or you don't need to do the HTTP GET, but you just want to check the validity of the TLS handshake, and so on. So the tasks TLS and TCP are subtasks of HTTP GET in a way. And HTTP GET is designed to give you basically all the information you might want to need. But again, if you do the HTTP GET using the system DNS, the DNS queries are probably cached because we are using system resolver. Yeah. So again, let's go to this description of this task. And as you can see in the database description at the bottom, you will see what information you have in the raw metrics for a task like this. Yeah. So again, if we are doing a full HTTP task, we actually can split it into TCP timings, TLS timings, time to first byte, timing of the full content download, the total time, and we can have information if it was TLS communication, if the certificate is valid, how many days until expiration.
And status codes.
Yes, obviously we also have the status codes. We know if it was success or an error. And for all of the tasks, I think we need to tell you right now, we will also add an IP address. So because we are doing connections, we will also be putting the IP address of the device that we connected to during the execution of this task. And we added a meta field called target ID, because for some reasons you might want to have the same target ID even for different tasks. So this is an optional field that only is designed to help you organize what you do. And then every second we do the aggregation of those data. We did whatever we could to not lose any important information. So we have average timings for everything. We have maximum total time, sample count, percent of success rate, and stuff like this. All right. So what is also important when we go to the task list is that when you do the DNS query, so when you have the task that is specifically designed for DNS, it is not using the system resolver. So it's doing the DNS call every single time you specify the task to do it. Okay, so this is actually to evaluate the SSL servers. HTTP content is designed in such a way to have ability to analyze the context. So basically you do the request, you take the content, and then you can design a regexp that if you find anything within this regex, it means, okay, if I found something using this regular expression, it means that we are passing the test. So the reason for that is that from time to time, we know that the application can actually answer you with status 200. You have all the answer, but the answer is, I don't know, we have the maintenance window or whatever else. So this was the idea behind it. And it allows you some more flexibility to tell if you passed or didn't, and to have additional criteria for that. All right, and one more task that is probably worth mentioning is bandwidth. And the bandwidth task is basically always between agents and server. So you are not able to do any desirable location that you want to do. Yeah. So probably you can do it as an HTTP GET task. Yeah. So if you are going to do the HTTP GET for a certain file to download, then you kind of have your bandwidth test for anything you want. But this bandwidth test is designed to measure between agents and servers, because again, we didn't want to do too much flexibility in this one particular area. We tried to have the queue on the server side. So, if multiple agents ask for the bandwidth test at the same time, the server will try to do it one by one. So the measurements are not distorted by having multiple measurements at the same time. And as you can see at the bottom, there are two additional queries. They are called SQL query and SNP query. And again, they are, let's say, optional. So what do I mean by that? The name of the project is LinkSense. We want to, start as a tool to evaluate LinkSense. But it turns out that if you already have what we do, it's possible to find use cases to be able to do SQL queries or SNP queries from the agent themselves, especially when you have them, across multiple distributed networks. But again, this is not their prime design. Yeah, this is not in the core competence of this program. The ability is in there for some people to use, but again, it is additional extra, I would say. Okay, let me know if you have any questions. Marcin, maybe you'd like to add something about SQL or SNMP, your favorite tools?
Yeah, so for SQL queries, I think that the best part is that you can actually count rows that are a part of the query result. So for example, you can check not only if the database is online, but if the data itself is accurate. Do you have information inside the database itself. So that's not only up and down status, but also you can verify the data itself. So that's great. As for the SNMP query, as Maciej said, it's a bit additional task for us, but you can in fact define custom OIDs, like for example for CPU, or maybe like basic ones like host name, or vendor, or node description, or something like that. So you can also do that as well if you prefer.
All right, thanks. So I don't see any questions, so I'll move forward to the demonstration. So let me show you my console. So this is basically what runs locally. So I spawned an agent. It might be in a slightly older version, or maybe this is the version that is official, because as I said, we have the beta version that Marcin is testing right now. So as you can see, all you need to do is start the program if you want it via command line. And again, it's by design that we are not pushing the logs to the standard output. We do it like this because it's designed to work offsite. It's designed like this. So if you want to review the logs, you should do it in the log files that are also available to you. So let's see how it is. Let's see how it is working. As you can see, this agent is working now for, I don't know, 49 minutes. It's using 31 megabytes of memory, and it uses barely any CPU. Yeah, this is on my host. So obviously there are many, many different processes running right now. So the CPU usage is probably the highest due to the streaming I'm doing for you. But again, this process, its range is basically from 0 to 1%. Like, it's almost nothing. So you might ask, okay, so how many tasks do we do for this particular configuration? So let's move to configuration and see how many tasks I have configured. So as you can see, I am doing multiple pings. So I'm pinging multiple DNSs, example com, and OpenDNS. I'm doing some simple HTTP gets every 12 seconds. So I'm doing all those things for like 5 times a minute. And because I don't want to stress the infrastructure that doesn't belong to me, I also have tasks that are on my own server. So I created the server. Hopefully it will not be overused by people who have seen this webinar. If they are, I will have to change the address for that. But this is basically LLS, so local sleep server. So it is designed like this, that when you go to here, it basically will sleep for 1 millisecond and then give you a simple answer, okay, or something like this. So because this is my own infrastructure, I am able to do some more testing. So as you can see in here, some of those tasks are commented out because, again, I was doing stress testing and different configurations. But in the end, I am doing quite a lot of testings. This is done every second, and this is also done every second, but the sleep is longer than 1 second to test, how the program behaves if I'm trying to do something that takes longer than 1 second. And obviously, I have some more HTTP gets. I have some TLS checks, TCP checks. So there are quite a lot of tasks, as you can see. So this is, again, to show you how minimal the usage of this particular agent is. I'm not sure if I have the bandwidth executed in there. Probably not, because we would see it in here. So very little usage of resources, both in terms of operating memory or CPU. So you might ask, okay, so how does it look like on the server side? So this is the server that my agent. So no, I see. Yeah, I see something in here. We'll see in the database in a bit. So this is on the server side. So on the server side, again, as you see, this is running for 53 minutes because I restarted everything before this webinar. But I want to tell you that But I want to tell you that we did long-run testing for this software as well. We are running it for over a month or anything to check if there are, any memory leaks or any problems like this. And yeah, I put a lot of time to make sure that this is running as efficiently as possible. This is obviously also one of the reasons why we decided to use the Rust as a programming language to deliver this software. So again, as you can see, everything is running in a very, very simple way. I can also show you that this is the configuration that have been sent to the server by an agent. So right now, what should happen is if I were to change the configuration, I'm going to check the bandwidth. No, the bandwidth is enabled, so it probably works from time to time. So if I were to enable some tasks, so let's enable those tasks that run every second. And again, what I'm doing right now is I am editing the configuration file on the server side. I think this should be okay. And again, I don't do it very often. There is a instruction for this. So let's move in here. And as you can see, there is the reconfiguration feature. And the reconfiguration feature look like this, that this one is monitor for bulk updates. So if I were to change the configuration of multiple agents, I can put it in here. So right now, I will be honest with you, I can't remember if the tasks will be reconfigured if all I did is change the configuration on the server, but we will see it on in here.
It should, I think.
I think it should as well, yeah, because it should be watched. Oh, and as you can see, this is already new, uncommented on the client side. Yeah, so the configuration already changed. So the last thing that we can do is we can go to the evaluation of the databases. I have quite a lot of them, but this is my base. I can reconnect to this. And what we changed, I think it was this one. Yeah. So I can go to data, not aggregated, but raw metric HTTP. I can go to data, and as you can see, those are the tasks that I have just uncommented. Yeah. So I uncommented the tasks on the server side. The server noticed, okay, for this particular agent, I have the newer configuration version that the agent has. The agent, when it was doing the next update to the server, said, okay, if my configuration is stale, dear server, please send me newer configuration. The server sent it to the agent. The agent validated it, updated it, and started using it immediately. Yeah. So as you can see, all the metrics, raw and not raw, are here. Yeah. So again, we are not flashing the information to database immediately. We are flashing in batches. So again, right now I'm just refreshing the database, and as you can see, there are many, many more entries. Yeah. The number is 96. We can wait like 5 seconds, and the number is 33. Yeah. So all this is running very, very efficiently. Without any issues. We did really long-term evaluation. About like our longest running for the testing period was 1 month, and for a large number of tasks, because I was stress testing my own infrastructure, and it was like without any single problems. Okay, guys, let me know if you have any questions. So again, you can review the database in here. As you can see, for this, I also have the information. I can show you the aggregated metric, for example, for HTTP or whatever you want, and everything is here, everything is working. We evaluate everything, it calculates properly. Even for bandwidth tests, we also see how much bandwidth we have for this particular connection. All right. So last thing to note, and this will be like the introduction to the part of integration with Sycope. So as you probably noticed, by design, the LinkSense itself doesn't have visualization. It doesn't have alerting or stuff like this. Why? Because it's a monitoring tool. It's a data gathering tool. As we noticed in our discussion, there were no open source solutions for monitoring, but there are multiple solutions for visualization, alerting, orchestration, or whatever you want. So the assumption is that you probably already have some kind of system, if you're especially large scale corporation, that you might want to use for either visualization or alerting. Yeah. So we didn't want to, do something that will be too large. So again, thanks to the fact that we have no alerting and no visualizations, all of those solutions, as you have seen, are extremely efficient in terms of research usage, right? So we said that with the version 1.0, we will start integration with outside systems. And obviously, as we were both working Sycope, the first system that we did the integration with is Sycope, because, well, we basically use this software for some of our customers. So they wanted it to have it in Sycope, so they will. But I am extremely open to have it integrated with basically anything else you might want to. But all I need to do is know which direction to go to. So if you have any opinion on that, what should be our next target for data forwarding, let me know, and I will be eager to add it to LinkSense. Okay, Marcin, so maybe I'll stop screen sharing and you will tell something about the software. So we have a very cool question on chat. Just let me stop screen sharing. If we plan to release a containerized version. So yes and no. We are thinking about it, but we are actually not certain what kind of containers you might want for that. So again, you need to remember that this is just a very simple binary. Yeah. So we made sure that the deployment procedure is as simple as copy binary and start service. So the moment you start doing that in the container, which you obviously can do it on yourself. Yeah. So all you need to do is do your own Docker Compose or Docker file where you copy the binary and start the service and you're done. So again, right now we don't see that much value added by providing the containers ourselves. It's extremely simple to start it in container yourself, but you start losing the argument of extremely low resource usage. You can use Alpine Linux with containers, and there is a Moose build for that. We didn't test it personally, but it should work. Okay, Marcin, go ahead.
Okay, thanks a lot, Maciek. First, I would like to thank you for creating this project, because it was something that we really believe that will be very useful for users. And for me personally, I was very excited to use built-in synchronization in LinkSense. It is still on as a preview for us internally. However, we will have it published in GitHub in a while. So first, let me show you how it looks in Sycope in raw data, because you saw how it looks on SQLite. So maybe we can start with that step. So here we have raw data, and I can switch from one of our NetFlow streams to our custom LinkSense streams, and those are link, bandwidth, DNS, HTTP, ping, SNMP, and so on. So here, let's say I want to check HTTP, And you can see I have few domains that I'm monitoring using around 3-4 LinkSense agents. And I can scroll to see success rate, average TCP time, as well as TLS, download time, total time. And something that I wanted to highlight is that we have average, max. So we can actually check between aggregated samples what is the maximum potential latency within a certain period of time, like for example in minute intervals. And here you can see successful requests as well as failed requests and status code. So you can see a complete picture of why it failed, what is the status code. If you include HTTP content, then you can also see if the website inside includes certain information that you require. And we also have IP address. So the domain resolved IP address is also stored within the time sample. So we can see how the IP address is actually changing over time. And we can also check how, for example, ping looks like. Here you can see min, max, average latency, sample count. So in Sycope, we are aggregating samples within minute intervals. So if you are pinging a certain node more than once per minute, then you will have sample count more than one. So in here, most likely I am pinging that every 30 seconds. So as you can see, it's almost, I think, 1 by 1 in terms of raw data in LinkSense server. And the synchronization is within the LinkSense binary itself. What we need to do from the Sycope perspective is only to create the streams here for the data to be saved to. Okay, so what we can do with that data? So I have 3 dashboards prepared for today. Those are in custom dashboard style. And we can start with LinkSense Resource Monitor. And here you can see those are statistics only from LinkSense. So that's important part to mention. But the data is stored locally in Sycope because the synchronization is saving them inside our server. And I can check on the statistics using my mouse cursor. And you can see the different monitoring tasks. Like, for example, you have TCP chart. So here I'm checking the TCP port for Oracle Cloud, Microsoft Exchange, and Office servers. From here I have ping chart, and those are a combination of external and internal destinations. So for some of them you will see less than 1 milliseconds, but some are a bit higher, like Google DNS and so on. And I have also have the DNS result, DNS queries. Domain queries here, the Outlook, Office, and Sycope.com, our website, and HTTP chart for HTTP GET. And what I can do here is, for example, to filter that. But before I will do that, let me show you my configuration of tasks. And you will see here that I have one very interesting example, because I have different tasks for the same target ID. So I have Office 365 here for the task ping, as well as task HTTP GET, and few others. TCP, again TCP. So I have multiple tasks, different tasks for the same main group application, let's say, so target ID. And I can use this target ID to filter different types of tasks. So let's try it. So here I can click on filter. I can find target ID. And I have 2 target IDs configured present. So I have Office and Oracle Cloud. So let's choose Office. There you go. Okay, so now we are seeing all of the resources, but only for Office 365. And since I'm monitoring this kind of service using ping, TCP, DNS, HTTP, multiple different protocols, I have all of those charts visible, and I can check the statistics. Also, I can expand my time range here. So for example, to 24 hours. You can see that I have not enabled all of the tasks yesterday, so are enabled this morning. That's why we are not seeing all of the statistics, but yep, you can see the use case for that. And something that I wanted to show you today is the ability to check potential issues. So here I have a chart that is saying to me that there was an issue, but there was an issue only on one agent. So I have 3 agents currently, agent 1, 2, and 4. 3 is actually offline for now. And you can see here that the failure was 100% at this point in time. And on the right, you can see the same, but on the as a table. And here we have failure 100% and failed connections too. So that's again the same aggregation as I mentioned. So here I'm using a minute sampling. However, there were probably 2 samples every minute. So that's why we are seeing 2 failed connections. And what is quite nice in terms of this kind of grouping is that you can see, firstly, that it is only being reported by agent 1. So the way how you can implement that is to take agent 1 and put it in the site A, agent 2 inside B, and agent 3 inside C. So you have 3 different sites. Maybe they are in different location, different office, maybe different country. And the idea is that you can actually see your services. Those can be in the cloud, external, internal. To be honest, from the LinkSense perspective, it doesn't matter. So you can use anything that you need. And you can see from which location, from which sites, there is a failure. And what kind of failure, how many times over a particular time. And you can see here we have a timestamp when this failure occurred, only for agent 1, as I mentioned. And we also have task name of the particular service. So we have Microsoft Exchange, Office, and the way how it works is that if one agent only has an issue, that means that the external service is most likely fine, because other locations did not mention anything about the failure. So in this example, I would try to find an issue within the network connection for this agent. So that would be most likely a local issue to analyze. So very easy to pinpoint potential issue for a particular service. And the more agents you have, the more picture you can create in Sycope. So if you have, for example, 10, 20 agents in different locations, maybe different offices, even different rooms, depending on how your routing is configured, that can be also beneficial. Okay, so let's check out other dashboards. So for example, I have created a dedicated dashboard for Office 365. And this one is a bit different because you can see here on the right that I also have IP addresses and max connected time, total time. And from here, you can see how different services are behaving. So here I have LinkSense Office 365 per service. So I can see which type of services have the highest latency, or if there is a failure. And here I have the same chart, but it is per agent. So here I see that the agent with the highest total timeout, I'm sorry, not timeout, the total time for resolving the request is around 1 second, let's say, more or less. So that's quite high. And it is only for the agent 2. So you can see how you can use this in terms of different locations. And on the right, you can see those 3 agents with the IP address, and those IP addresses are the resolved IP addresses of those services. So you have Exchange service, IMAP, SMTP, sorry, and you can have the total time connection. And this is quite nice because we are actually using our color palette that is automatically coloring all of those fields. And I can use, for example, last 24 hours and see exactly how the total connection looked like. And this is quite nice example here, because you can see that the agent 4 in the last 24 hours did not have any larger response time, but the 1 and 2 had. So here you can see maybe it's a network issue, or maybe that you just need more data, like for example from the last 7 days to make to create a better analysis. But it gives you some overview of the situation. So for example, if a person from site A was reporting that the application was running a bit slow, then you can check, and indeed, from the LinkSense perspective, it had some delay in response. So that would correlate to a user that is reporting the same. But from the site C, agent 4, we don't see any issues. So if you would see a particular end user that is saying that something is working a bit slower, then you can check from here, and you can see that you don't see any issues. So you could, for example, analyze only that particular machine that the user is working on. And to add something here, because LinkSense is compiled to practically any architecture, any operating system, so you can actually install it on the end user machine if you prefer, and you can use this to analyze end user perspective. So you can create multiple tasks from that user and see if indeed there is a problem, and analyze and go from there. We can also check one last dashboard, and this one is dedicated for our API check. And you can see here that we can check the latency from those 3 agents. And this is the latency for our website. Here we have total time in milliseconds and the max total time in milliseconds, and at which time stamp in time period it happened. So you can have the right information when exactly there was a delay. And for the HTTP task, we are also monitoring SSL days until expiration, so we know when we need to renew the certification. And we also have status codes. So here I have 200, so that's great. We are good. And if you would, for example, have anything else like request failure or different status code, or maybe HTTP content is wrong, then you can use our rules for alerting. So that's also an option for you, because if you have the data within Sycope, you can use any kind of tools that is on your disposal on the system. So that's also great to have. And as for working with this kind of data, it's very easy from the Sycope perspective. So you can quickly click on settings, edit, and from here I can change, for example, average latency to a different statistics. Like, let's see. So we have average latency. You can even have a preview of the current values. Failed pings, max latency, minimum latency, package loss. So anything you like. So for example, I'm using average latency, but let's say we want to have max latency. So we can use that with max, like this. I can remove the average. And now I have a chart with a bit higher level of samples. So very easy to modify, very easy to create. It's simply you can simply use the wizard. You don't need to use any kind of raw queries. So very easy to do. And I can save it. And now I have a new chart with maximum latency instead of average latency. So very easy to do.
Thank you, Marcin. Thank you for this work, because Marcin is much better than I am in creating dashboards and having good ideas what to show on the dashboards in Sycope. So guys, we wanted to show you this because, again, LinkSense give you, we think, all the information that you might need, and you can visualize it in your system of choice, whatever it is. Again, remember, the data is stored in very simple tables in SQLite. So obviously I will write hopefully any forwarding that the community might ask me to, but it's extremely simple to write your own integrations, because all you need to do is take data from SQL and copy it somewhere else. So even if I am not supporting the integrations officially, let's say, it's extremely easy to do integrations like this to any kind of systems. All right, so we have 5 minutes left, so we usually leave the last 5 minutes for any questions you might want to ask. So feel free to ask any questions. So on the chat, there are also links to Discord. We created a channel for LinkSense in there. There is also a text channel for General, who just came to us. Some people I see are coming to here as well. So again, feel free to join on Discord. Feel free to email me, set up an issue on GitHub. We are supporting it, monitoring it. And I really hope you will use it. You will find some issues, but not the buggy ones, but maybe the more like feature requests. Because again, this one of the things that differentiated from Vibe coding is that we tested a lot. Yeah, we tested a lot. We are certain that it is working correctly as intended. So yeah, I don't think you will find the issue, but if you will, I will try to fix them as soon as possible. Okay. Thank you very much for today. Thank you for your presence. Feel free to use our software, to recommend it to anyone, to ask me questions. Thank you for everything, and have a good day.
Thank you.